Hi guys, welcome to our video that we're going to learn how to graph quadratic functions that are in standard form. We spent the last few days graphing quadratics that were in transformation form, but when we can't see the transformations straight from the function, we have a different way to graph them. So for instance, let's look at what standard form is and see what all these letters represent. Here is the standard form function of a quadratic. It is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. And obviously our variable x is our input, f of x is our output. Now a is a lot like it was in transformation form. If a is positive, our parabola is opening upward, which then makes our vertex a minimum. But if a is negative, it reflects our parabola, and we now have a maximum value for our vertex. We talked about increasing and decreasing intervals in the video before, so those are on here as well. When we graph a function from standard form, we are going to find a total of 5 points that we graph. So I'm just going to write that here. We will graph a total of 5 points. Okay. And how we find those 5 points, the first thing we do is we find the axis of symmetry, which we know is that vertical line that cuts our parabola in half, and we have a little formula that helps us find it. Oopsies, that's not what I wanted to do. The formula is x equals negative b over 2a. So we use those letters a and b from our function. Now, because our axis of symmetry goes down the middle of our parabola and straight through the vertex, that same little formula is our x-coordinate of our vertex. So let's remember what that is. So because it is the x-coordinate of the vertex, we can plug our axis of symmetry into the function. That's what this means right here. See f of negative b over 2a. And that can give us our y-coordinate of our vertex. So that's 1 point. We will also get another point from finding the y-intercept, and that's super easy when your function is in standard form. It is just your c value, so it's 0, c. Finally, what we will do is once we plot the y-intercept, we'll plot its reflection across the axis of symmetry, and then we'll use substitution to find another point. So let's get to it. Graph each function by finding its vertex, axis of symmetry, and y-intercept. Use symmetry to plot at least 2 additional points and tell whether the vertex is a minimum or maximum. So I have the order in which is the easiest to do these things listed under each example. First is f of x equals 3x squared minus 6x plus 1. Our formula for axis of symmetry is x equals negative b over 2a. So we need to identify what a and b are, and while we're at it, let's identify c. Remember that a, b, and c are the coefficients of our x terms, and then our constant at the end. So a is 3, b is negative 6, and c is 1. Okay, so for my axis of symmetry, it is x equals negative, and then I have b over 2 times a. Now, when I take a negative times a negative, that's going to give me a positive. So I actually have positive 6 over 6, which reduces to 1. So my axis of symmetry, I will write x equals 1. And I'm going to go plot that. That's the vertical line at x equals 1. Now, I know this line goes through my vertex, so I can plug this x value into my function to find its corresponding y value. So to find my vertex, I already know the x-coordinate is 1. What I need to find is the y-coordinate. So I'm going to find f of 1. So I'm putting 1 in for every x value into this function. So 3 times 1 squared minus 6 times 1, and then plus 1. Following the order of operations, in this first term, I should square 1, which is 1, and multiply times 3. That's 3, minus 6 times 1 is just 6, and then plus 1. And 3 minus 6 is negative 3, plus 1 is negative 2. So I knew my x-coordinate is 1. Now I know my y-coordinate is negative 2. And I'm going to plot that on my graph. There is my vertex. Now it asks me, is my vertex a minimum or a maximum? Well, because A is greater than 0, it's positive. We know our parabola is going to be opening upward. So that means our vertex is going to be the lowest point, a minimum. Okay. Our y-intercept, remember, right here is 0, c. Well, our c value is 1, so that's going to be the point 0, 1. Now here comes all of our points. So 0, 1 is right here. And what I want you to do once you've graphed that is graph the y-intercept's reflection across the axis of symmetry. So it's 1 unit away, so there has to be its reflection across. So now we have 3 points. To get our last 2 points, we just pick another x value to plug into our function, and then we can reflect that point over the axis of symmetry as well. I would pick a point or a value that's easy to do mentally. So I would pick close to my other point. So I'm going to pick positive 3 because it's right to the right of 2. All right, so f of 3. That's going to be 3 times 3 squared minus 6 times 3 plus 1. The first thing we are going to do is do our exponent. 3 squared is 9. 3 times 9 is 27, minus 6 times 3, which is 18, plus 1. 27 minus 18 is 9, plus 1 is 10. So I put in 3 and I got out 10, so that is the point 3, 10. I'm going to go plot that, and then I'm going to plot its reflection across the axis of symmetry, so it's 2 units on the other side, which is the point negative 1, 10. And finally, I have 5 points that will help me draw a parabola as best I can. Here we go. All right. Okay, guys, we're going to do the next 2 in class tomorrow. I hope you have a great day.